we're going to go ahead and talk about solving equations with fractions, okay? And these are algebraic equations. So like you've done these before where you had like x plus 3 equals 12. And remember, you had to use algebra to solve for x. Okay, so let's just review how we go about that. And I know you can eyeball this, but again, I want you to understand the process and the steps because you will need to do this for the fractions, and you won't be able to just look at it and figure it out. Okay, so remember the whole point of doing this is to get x by itself. You want x equals whatever this mystery number that x is. Okay, and what we did to do that was we had to get x by itself. So we had to get rid of this plus 3. Okay, so remember we talked about opposites. Remember what's the opposite of adding 3? Subtracting 3. So we had to go ahead and subtract 3. Okay, and now that was gone. And remember with algebra, you can do anything you want to one side of the equation as long as you do the exact same thing to the other. Because remember we got that balance and now it's off balance. So if we subtracted 3 from this side, we have to do the exact same thing over here. Okay, and so now bring the x down. X is equal to 9. All right. So now let's apply that to fractions. And really, it's just the same idea. Just instead of whole numbers, we have fractions now. So let's do x plus 4 2/5 is equal to 7 4/5. Okay. So this is our equation. Again, we've got fractions, and don't let that scare you. Just remember that basic process. We're going to do the exact same thing. Instead of whole, we have fractions. All right. So we've got our x. Remember, we want to get the x all by itself. So we have to get rid of the plus 4 2/5. Okay. So what's the opposite of adding 4 2/5? Subtracting 4 2/5. Okay. So that's gone. So remember what we do to one side of the equation, we have to do the exact same thing over here. So we're going to go ahead and subtract 4 2/5. And look at that. They're even the same denominator. Wasn't that nice? All right, so now we're going to rewrite the x and go ahead and work this out. 4 minus 2 is 2, and then the denominator stays the same. 2/5, 7 minus 4. Okay, x is equal to 3 2/5. Okay. Let's do another one. Okay, this one's written a little bit differently, but don't let that fool you. Okay, so now we've got 5 2/4, so we're adding that to g. I mean, it says 5 2/4 plus g, but we're adding them together. So either so you could say we're adding g to 5 25 over 24, or we're adding 5 24 to g. Either way, I mean, they're being added together. Okay, remember that. Okay, equals 1/3. Okay, so now here's our variable. We want to get g by itself. Okay, remember we're adding 5 2/4 to g. Okay, so we've got not 5 2/4, 5 over 24 to g. Okay, so we've got to get rid of this. So remember, they're being added. So what's the opposite of adding 5 over 24? Subtracting it. Okay, it's gone. So now we've just got the g. Don't worry about the plus. Okay, so we subtracted 5 over 24 from here. So we've got to do the same thing over here, minus 5 over 24. Okay, so now we've got an instance where we do have different denominators, so we need to go ahead and get the same denominator. So the least common multiple of 3 and 24 is 24. Okay, so we've got to convert this to an equivalent fraction. 3 times what is 24? Times 8. The same thing here, times 8. Okay, 8 over 24. Okay, so now we can go ahead and subtract. We just left this one alone because it was already over 24. So we're going to go ahead and rewrite this. G is equal to 8 minus 5, that's 3 over 24. All right. Oh, that's not showing up very well. Okay, 3 over 24. Now, is this our answer? Yes, sort of, but but remember, answers always have to be in simplest form. So 3 over 24, let's simplify that. Well, we know 3 goes into 24 8 times, so G is equal to 1 over 8. Okay, let's do a couple more of those. I kind of threw a really tricky one at you right off the bat. Okay. Let's do 11 over 12 is equal to n plus 2/3. Okay, so again, we've got our variable here. Our whole goal is to get the variable all by itself on one side of the equation. So what's in our way what's preventing that from happening? Yeah, the plus 2/3. So we got to make that go away. Okay, so we have to do the opposite. The opposite of plus 2/3, minus 2/3. Okay, that's gone. Again, what we do to this side, we have to do to this side. Minus 2/3. Okay, so, well, we've got different denominators, so we have to get a common denominator before we can actually subtract. Well, so least common multiple of 12 and 3 is 12, so we can leave this one alone because it's already over 12. So we've got to convert this one to an equivalent fraction, so 3 times what? Times 4. That means 2 times 4. All right, that gives us 8/12. Okay, so we've got 11/12 minus 8 over 12. And then just bring our n down. Okay, now are we finished? Almost. What do we have to do? We have to simplify. 3 over 12 is not in simplest form. Okay, so simplest form is 1/4. Okay, and then, you know, if you want to erase the 3/12 and make it 1/4, and that's fine, you can leave both there. As long as I see it in simplest form somewhere on your paper, like by your answer, then I know you've simplified. All right, let's work a couple more. Isn't algebra fun? Actually, I really do like algebra, and I know if you've worked with me for very long, you will have heard me say algebra is super, 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 super important, and it is. Okay, let's do 4/9 is equal to y minus 2/3. Oh, no, not 2/3, 2/5. Okay, so we've got our algebraic equation. Okay, so whole point is we're solving for y, trying to figure out what mystery number y is. Okay, so we've got to get rid of this minus 2/5. Okay, so think about math opposites. Okay, what's the opposite of subtracting 2/5? Adding 2/5. So we're going to add 2/5 here. That's gone. Okay, so if we do it over here, we have to do it over here. Plus 2/5. Okay, so we've got 4/9 plus 2/5. Okay, we have to get a common denominator. Okay, so least common multiple of 9 and 5, well, that's going to be 45. Okay, so I'm going to write it over here. And 45. Okay, so 9 times 5. Okay, so then we're going to do 4 times 5. Okay, that's 20 over 45. Okay, so 5 times what? 9. Okay, times 9. That's going to give me 18 over 45. Now we can go ahead and add them. Okay, 20 plus 18 is 38. And then the 45 stays the same. And then we're going to bring our variable down. So y is equal to 38 over 45. And let's do a double check to make sure that's in simplest form. And that is in simplest form. Kind of a big number, but it's in simplest form. All right, and that's our answer. Let's do one more, then I'll let you get to your work. All right. Okay, so we've got t minus 7/9 equals 1/3. Okay, again, trying to get the t by itself. What's in the way? The minus 7/9. Okay, so ask yourself, what's the opposite of minus 7/9? Adding 7/9. Okay, so we're going to add 7/9. That's gone. So we're going to add 7/9 over here. Okay, let's bring the t equals whatever we get here. So we've got 3 and 9 have to get a common denominator. Okay, well that's going to be 9, so we can leave this one alone. So let's go ahead and make an equivalent fraction up here. 3 times what equals 9? Times 3, 1 times 3. Okay, so we've got 3 over 9 plus 7 over 9. Okay, so 3 plus 7, that's 10, and then the 9 stays the same. Okay, so here's our answer. Can we leave our answer in this form? No, it's an improper fraction. We have to turn it into a mixed number. So there's 9 pieces to it. We've got 10 pieces, so we can make one whole. So that's going to be 1 whole. How many pieces do we have left over? 1, and then still 9 pieces to make a whole. Okay, so t is equal to 1 1/9. Okay, so good luck on your assignment.